This is Learning Assessment Problem 912. The problem-solving strategy here will be the calculation of the effective or root mean square value of a periodic waveform. In this problem, we are requested to determine the power dissipated in a 10 ohm resistor when the periodic current waveform shown in the diagram is flowing through that resistor. The equation which we'll use for the power calculation is that P sub r is equal to the RMS value of this current squared times the resistance. So the first step will be to determine the RMS value of this periodic waveform. We'll define the period over the time interval 0 to 8 seconds. So t is equal to 8 seconds. And the procedure for calculating that RMS value will be as follows. The first step will be to square the current function. Then we'll integrate that current over one period. Then we'll take the average of that integrals of the current squared by dividing by the length of the period. And then we'll take the square root of that result to determine the RMS value of the current. So this will be the calculation of the root mean square or effective value of the current. For the current situation, we have that IRMS is equal to two components here. We have a plus 4 ampere square pulse and followed by a negative 4 ampere square pulse. So in our integration process over one period, we'll have the contributions of those two pulses, the square of their amplitude in the calculation of the integral. So here we have the two square pulses, one of plus 4 ampere amplitude and the other minus 4 ampere amplitude. But when we square those, both of those areas become positive areas when integrated over their respective 2-second intervals. Average that squared integral by dividing by the period of 8 seconds, and then take the square root. And the result is that this is equal to the square root of 8 amperes RMS. Now to calculate the power dissipated in the 10 ohm resistor, again the equation will be P sub r is equal to the RMS value of the current squared times the resistance value. In this case we have the square root of 8 amperes squared times 10 ohms, or the power dissipated or absorbed in the resistor is equal to 80 watts here. It should be noted here that even though the current waveform has an average value of 0, its effective or root mean square value is a non-zero quantity.